training new people is very, very important. So if you're going to pick a language, it has to be easy to learn. And this is actually one of the big reasons that we adopted Go at Inviqa over other options such as Rust. Cool. So this talk is called Grasping Go. And we're just going to look at what is Go. We're going to look at what I think some of the best features of the language are after using it for a few years. And we're going to look at that, that all important question. If I use Go, how is that going to improve my life as an engineer? I think that's, for me, when I want to use a new language, I want to know what it's going to make easier for me. But then just as important, we're going to look at some of the drawbacks or some of the limitations of using Go. We're just going to touch on a few of those. And then we're going to wrap up with, what is beyond this talk for you if you are new to the language. Where can you go to get more information, to get started with programming in Go? So what is Go? Well, obviously, it's a programming language. It's an open source language, so it is driven by the community. It is driven largely by Google as they created it back in 2009. And it was 3 guys at Google who were frustrated with languages like Java and C++, which were predominantly used at Google for their backend systems. Now, those languages are still predominantly used, but Go is increasingly more popular at Google. And what they wanted to do when they designed this language was really just dial in on the simplicity. So in Java and C++, there's a lot of bloat. So you could say there's a lot of features in the language. Some people would call it bloat. There's a lot of ways of doing things. And in C++, the build times are quite slow as well. So they were trying to get away from that and create a simpler solution. And just for reference, Go has about 25 keywords, and PHP has around 69, and TypeScript has about 60. And I think Python has around 33-ish. So we get an idea of how simple or how small the Go specification is. It's a strictly typed language, and by that we mean that every value we define has to have a type. And it has a load of different types that you will come across. I'm not going to go into the syntax too much here. It's very difficult to cover an entire programming language in 30 minutes. We will see some code shortly. It's also structurally typed. Now, this is different to languages like PHP and Java, which are nominally typed. Again, I'm not going to go too much into that here, but have a Google afterwards if you're interested in nominal typing versus structural typing. But basically, when we talk about structural typing, we're talking about, when we compare 2 types, the actual equivalence is determined by their structure or the definition. Now, in order to execute a Go application, we have to build it. So it's compiled into a single binary. And this makes it really, really great for things like command line tools. Because if you, for example, were to build a command line tool with PHP, you have to have your users of that command line tool install a PHP version on their machine. Now, when you compile an application with Go, it's compiled to machine code, and it's compiled for that operating system and architecture. So we'll touch again on this later as to why we've got some other benefits here. Code is organized into packages in your applications. So if you come from PHP, you'll be used to namespaces. You come from JavaScript, you'll use modules. In Go, it's packages. And also, I think a really cool thing to wrap this section up is that Go is self-hosted. So by this, we mean that Go is written in Go. And up to about Go 1.5, I think, the Go compiler was written in C, and then they decided to rewrite it in Go. So the entire ecosystem for Go is written in itself. So the standard library, all of the packages that you'll use in the standard library, and the tooling is all written in Go. And this, again, has really good benefits we'll see later on, but also it's a great way of seeing how good Go code should be written, because in your IDE, you can explore the standard library and see how the code is organized and put together. So what are some of Go's best features, certainly from my perspective? Well, the first one is that, generally speaking, Go, it uses very low resources. It's very memory efficient. It's very CPU efficient. Of course, your mileage is going to vary because you can obviously write terrible Go code just like you can in any other language. But generally speaking, you're going to have, you'll be able to get more bang for your buck out of those resources you have available. Now, we mentioned that Go needs to be built in order to be executed. And if your build times are really, really slow, that's going to become really problematic when you're following test-driven development. You know, you write your tests and then you're running them repeatedly until they pass. Well, the guys at Google got really frustrated with build times for their C++ systems. And this was one of the main requirements with Go when they designed it, is that the compiler had to be very, very quick. And the new version of Go has actually just been released, I think, last week. And they've boosted the build times by potentially up to 25% in some cases. So they're constantly improving this Go build step. And we can see this like a typical build from one of our applications at Inviqa. So we're not, we see there 2.8 seconds. We're not talking like, a hello world application. This is a real web service. So these are the build times that you can expect. And also with Go, I think for people coming from PHP and say Node.js or JavaScript, sorry, it can feel like an interpreted language as well, because Go gives us this Go run shortcut where you give it your Go file, which is in this case your main.go, the entry point to all of your applications. And what it will do is it will build the application and then it will run it straight away. So you skip that manual build step when you're doing your development. Again, it's all thinking about the developer and trying to speed up the development workflow. Now in JavaScript, you'll be familiar with NPM packages and Yarn packages, composer packages in PHP. We have pip packages in Python as well. With Go, it's called Go modules. So this is exactly the same kind of concept. It's a Go module is a collection of packages bundled into a library that you can install into your application. So this is really good for reuse. Now, I think this is my favorite feature of the language, and it's the way that it handles interfaces. So in a lot of languages like PHP, we have to explicitly declare that our type, or I say our class, implements an interface. Now, this isn't the case with Go. In Go, you implement an interface literally just by implementing the methods, and you don't have to say explicitly that you implement that interface. And I think this is clearer by just looking at a code sample. So I appreciate for some people this may be the first Go code that you're seeing. Hopefully, it's fairly simple. You can make sense of what's going on here. We've got a person type with a name, so they just have a name. And then we have this speak function, which is going to return a string, and it'll just say what their name is. Now, in our main function over here, we're going to create that person, and then we're going to pass it off to this communicate function, which is going to print out what that person speaks. Now, this is great, but we're dependent on this concrete type of person, and we probably want to use an interface here if we can. So let's say we've introduced an interface. We've defined it simply with the speak function on, and then we have changed our communicate function here, so it now accepts this interface instead. And this will compile. And notice that on the left, we haven't actually had to explicitly state that our type implements this interface. And you may be thinking, well, why is this important? Well, if you think about the code on the left, if that code is outside of your control, it's either in a different package maybe, or it's in a third-party module, which you can't actually edit. You can actually define interfaces at the point that you use them, which is over on the right side here. And the code on the left has no idea that it's actually conforming to that interface. So when you're doing your mocking with your tests, you only have to mock that particular interface, and you don't have to mock concrete types that come from this third-party module. And it really does make your life easier when you're writing Go code. And then again, we can see a riff on this now. We just start to add in additional types with more uses or more implementations of that interface. And then probably the standout feature that everyone will talk about with Go is its support for concurrent programming. And Go really does excel here in terms of the simplicity of doing this. It's probably the simplest implementation that I've ever seen and ever used. But traditionally, multi-threaded concurrency has been complicated to implement in userland. If you did it in something like Java, for example, you have to start thinking about threads and thread pools. You may be wondering why do I even need to care about concurrency? Well, there's a lot of cases for concurrency, especially in the web space. They're all over, really. You can consider, for example, reading from a file and then writing it out to some other data source, or you may be reading from a file and wanting to write it out to multiple different data sources. And that's a great use case and quite a common thing to do with web services. Might not be a file that you're reading from, it could be a database. Now, when we talk about concurrency, we're talking about dealing with a lot of things at the same time. Or so we're talking about dealing with a lot of things at once. So the way that the human brain works, it operates pretty similar to a concurrency model. So if you're doing two different things at once, your brain is just switching between them very, very quickly. So conceptually, they are progressing at the same time, but really it's just switching between those two different things. And this is very similar to how a CPU with a single core would handle a process. It would schedule different threads onto the CPU so that it gives each of them equal processing time. Now, when we talk about parallelism, we're talking about doing a lot of things at the same time. This is, say, if you have two humans working on the same problem, they are doing things in parallel, you've got two brains on the problem. In computer terms, this is when you have a CPU with multi-core, and you can actually run two different processes at the same time. Now, when we're working with Go, we want to break our problem down into concurrent units, and we'll look at this shortly. Now, Rob Pike was one of the guys who designed Go, and he did an amazing talk on this very topic about concurrency and parallelism. And I really recommend watching this. So I'll share this in the meetup or in the chat after this talk. It's only about 25 minutes long, and I really recommend that you watch this if you're interested in working with Go. But he says that before we can even think about efficient parallelism, we need to break our problem and our application into concurrent units. And luckily, this is what Go excels at, because Go gives us Go routines. Now, a Go routine is basically an abstraction and a very lightweight version of a thread. And a thread is just a set of instructions within our computer application. So in this case, it could be the reading part of our application in that example we just looked at earlier of reading from a data source and then wanting to write it to somewhere else. So we've got a set of instructions there which would do the reading, and we might have another set of instructions which does the writing. Oops, sorry. Now, the good thing about using Go routines over something like threads with, say, Java is that Go will take care of the scheduling of these Go routines onto the threads. And another benefit is that Go will actually schedule them onto different cores, and we don't have to care about that. Once we've broken our application down into different concurrent units, i.e. into Go routines, Go can take care of the execution of those for us in the most efficient way. And it's really easy to use. So I think this is fundamental in being able to make the most out of a feature. For me, it has to be easy to use, or I'm not gonna really bother doing it. And let's have a look at another example just to illustrate this. So we've got a function here, and it's just going to print out a word 5 times. It's going to print, it's going to sleep for a few milliseconds on each iteration. And at the bottom here, we're going to call this twice. And the first call is with the Go keyword. And the Go keyword basically tells Go, I want you to execute this function in a separate Go routine. And that means that it's going to be executed concurrently with the rest of the application. And then it proceeds on to the next function call, which becomes a blocking function call because we aren't running that one in a Go routine. And when we run this application, we'll see something like this. It's a very simple example, but it demonstrates how easy it is to execute Go routines. And it also proves that they are running concurrently. There's only obviously one run of this application, and we can see there that the Go routine printing world is running at the same time, or conceptually at the same time. Okay, so we've got Go routines, but in our example before, we were talking about reading and writing. And for reading and writing to work, they have to have some way of communicating with each other. So Go has a second primitive, which isn't an entirely new concept. It was actually designed in a paper, I think, from like 1978. And it's channels. So these are basically like pipes for two different Go routines to send and receive data between each other. So again, let's have a look at an example. In this block of code, we're just going to define a channel. Now, every channel has a type, and this is, again, important for type safety. This is so that both sides of the channel, the sender and the receiver, know what data type is going to be sent and received. In the next line, this is just you'll be familiar with closures from like JavaScript and PHP. This is just a Go routine. So it's going to basically execute a block of code without us having to define an actual named function for it. So this function is simply going to sleep for 2 seconds, and then it's going to send the ping message on that channel that we've created there in the first line. And then the rest of the application is going to proceed, and it's going to print out the start time. It's going to receive that message, the ping message, print it out, and then print our finish time. Now, when we run this, we see that there's a 2-second delay between the start and the end of the application. And the reason for that is that this receive becomes a blocking operation. Until we receive that value on the channel, it won't proceed past that point. And we can start to get a picture of how you can have two different Go routines synchronizing their actions with each other through the use of channels. There's no synchronization primitives like locks being used here like you have in Java. This is all purely through communication. And I think this is probably one of the most powerful features of Go. And another feature that I really love about Go, and it's oft criticized for this, but the fact that it treats errors like any other value in your code. There are no try-catch blocks in Go. Errors are returned from functions like any other value. And it creates for, yes, quite a lot of boilerplate in some cases, but it creates a very readable code and also very safe code. And if we consider this example here, where we're trying to start a web server on port 80 in our web service, but port 80 may not be available. You may have something else running on that port. So we have to handle a case where that, we can't start up this service. So we basically just check that error value that's returned from our listen and serve call isn't nil. And if it's not nil, then something's gone wrong. So we can't do much else in this particular case other than bail out and panic. But in some cases, say if a database operation failed, you would want to log that and gracefully handle it. But the fact that the errors are returned makes it really hard to ignore them. You can ignore them if you really want to, but my recommendation is, follow Murphy's Law. If something can happen, it's going to happen. So handle your errors wherever they are returned. Okay, so in that section, we've looked at a lot of what makes Go great. And there is a little bit in that section which touches on, how that's going to make your life easier. Certainly with concurrency and the way that's implemented. But what are some of the other reasons as well? Well, the backwards compatibility promise that Go has is probably the best one I've seen in a programming language. How many times have we been on, say, a version of PHP and we want to update it, but we can't because there's been some backwards compatibility breaks, or we just don't have that confidence that everything's going to continue to work. Well, the Go 1 specification says that anything that's written for Go 1 during any lifetime of that will continue to work in the future. So if you've written an application in Go, say 1.4, it's still going to run today on Go 1.16. And the first version of Go came out in 2009. I think it was 2009 or 2010. And we're on Go 1.16 today. So we're 10 years on and we're still under this Go 1 compatibility promise. And I think that's great. When you're picking a programming language, you want confidence that you're not going to have to do a major overhaul of everything that you've written, especially in a language like Go, where you may have many different services within a single project using that language. It's also really, really easy to learn. Steve touched on this before, that training new people is very, very important. So if you're going to pick a language, it has to be easy to learn. And this is actually one of the big reasons that we adopted Go at Inviqa over other options such as Rust. Rust is a great language, but it takes a long time to learn. And Go is much easier in that respect. You can pick up Go and you can become productive with it in a few days. It does take time to master, like the concurrency primitives that we looked at earlier. Don't be put off if they didn't really make sense at first. They do take time to master and get your head around. But as a language to pick up that has type safety, is compiled, and has, you know, all the other benefits that we looked at, Go is really a great option. It's also garbage collected. So, you know, again, talking about making your life easier, you don't have to start worrying about managing memory, you know, allocating memory, deallocating it. The only thing you need to be careful of with a garbage collected language is the number of value allocations that you're doing. So basically, anytime you define a variable, you're actually going to give the garbage collector more work to do, because it has to clean that variable up when it leaves scope. So when the current function that you're in, for example, ends, it has to clean up those variables. Now, the fact that it's garbage collected doesn't mean that it's a good choice for, you know, video game development. You're not going to go and implement a video game unless it's a very simple, like pixel-based game with Go, because every time that garbage collector runs, you're going to see a frame rate drop. But in the space, like for web services and web applications, command line tools, you're really not going to see any issues with the garbage collector unless you're doing something crazy. It also has its own built-in testing framework. So, you know, day one on a project, you come in and you think, right, okay, what testing framework am I going to use? What testing library? You don't have that on Go. You get going with your project development immediately, and the Go test framework gives you everything you need. It's very simple. You can add to it if you really want to. I never really bother. I just use the Go test framework. And yeah, it avoids that conversation and that, you know, having to start pulling in libraries into your project on day one. And then building on top of that, it's got its own benchmarking framework. Now, I've not seen this in many other languages, but usually you'd have to pull in like a third-party dependency to do this, or an external tool like Blackfire. But with Go, you can run benchmarks. So you write them similarly to other tests. They have a special type that they use in their constructors, but it allows you to run tests. And Go actually handles all of the, how many iterations of this do I need to run to get a realistic benchmark, etc. That's taken care of for us. And what we can do is we can get an output like this by using the bench stat, or I think it's called bench compare actually. Now, this is basically the output from doing 2 benchmark runs, one on our old implementation of a particular application and one on a new one. So think about this maybe in 2 different branches of your code. And then we can run it through this bench compare tool, and we get this type of output. So we can see what was the old time, what was the new time. And then the most important thing here is, how much have I added to this actual operation? So in this particular example, I think we'd added a couple of extra database inserts, so it slowed that down slightly. But this is really good to know, and you can get this as part of your local development workflow. You can get this information without having to wait until you do like a full performance profile in an environment, for example. It's got a built-in web server. So if you're coming from Node.js, you're very familiar with that concept. Node.js has a web server there for you. PHP, you're going to have to pull in something external. You're going to have to use maybe Nginx or Apache. PHP has a built-in web server, but it's not suitable for production use. Now, the Go built-in HTTP server is a fully fledged web server. It can handle TLS termination. It can handle HTTP2. You can do graceful shutdown. You can implement throttling quite easily with it. And it actually has that slight advantage over Node.js with the signal handling, because Node can actually respond to signals correctly. It can actually then trigger graceful shutdown in the web server and allow any in-flight connections to be completed before it then actually terminates. And this is really, really important. If you're doing zero downtime deployments, you want to be able to deploy your new version of the application and have your old one cleanly finished before your new one is swapped in place. And if you use Docker to deploy, you're only having to use one Docker image. You don't have to have two, one for your web server and one for your application. We talked earlier, and we did see the go build command. We talked about that process, but the cross-compilation aspect of that makes it so easy to deploy command line tools in different architectures, operating systems, and you can do it all from your CI pipeline. Now, this is certainly not unique to Go. It's just a really cool feature, that makes your life easier. You don't have to start doing builds on specific operating system agents and things like that in your CI pipeline. It just makes it really easy to distribute things around. And I mentioned earlier, there's no dependencies on the on the host. So, it's basically a download and run, and you're away. It's got its own built-in formatter, but it's also got its own built-in code style. So, language like PHP, they've tried to, the communities have tried to converge on a code style. But my experience is still that when you switch between particular frameworks and off-the-shelf pieces of software, they all have their own opinion on how code should be styled. And this is similar in JavaScript and other languages that don't have their own built-in style. But with Go, it's there. You don't have to talk about it. You don't have this discussion with your team about tabs versus spaces for the 1000th time. It's again, just everything that Go gives us is all about trying to get you to solving problems quicker and trying to get out of your way so that you don't have to think about the tooling and about the language. And that is the mindset that I think you need to come to Go with. You need to come to the language knowing that a lot of this is taken care of for us. And that's okay. We can just dive straight into problem solving and delivering value for customers and clients. So we've heard a lot of good things about Go, and there's a few drawbacks that I'm going to talk about. There's probably more drawbacks to Go, but these are commonly the ones that I've run into after using it. So the first one is the fact that it's so simple, you're going to have some missing features. Union types is quite a common one. Like, we can't define type parameters that may be a string or a float or an integer, which is quite common. But realistically, I've not really come across that, causing me too many issues. Things like map and reduce, which you may expect from functional programming languages, aren't there. You can do functional programming with Go because functions are first-class citizens and you can pass them around. But if you wanted to use things like map and reduce, you have to either use a third-party module or write them yourself. But remember earlier that we talked about the fact that Go is written in Go. So the standard library is all written in Go. Well, that means that if you have to implement any of these things yourself, there's no penalty for that really, because it's all going to get compiled. The compiler is going to optimize things away. So you're going to end up with still a robust solution. It's also fairly complicated to model. So it's always fairly difficult to model complex domains as well. Go favors composition over inheritance. So when you have very, very complicated domains, it may be difficult, not impossible, but difficult to do with Go. So there may be other languages which are better suited to that particular application. Similarly to that, large code bases can be quite difficult to organize well too. And I don't think this is something that is a problem with the language. I think it's just something you have to get used to. I ran up against this problem a lot when I first started writing Go. And when I started to use implicit interfaces more, and not only using them, but using them at the point where I did my type hinting, like in the example of the speaker earlier, defining that interface in the same package and at the same point that I'm type hinting for it, it means that we avoid what we call package import loops. So let's say if we have an application, it's called my app, and it imports a package foo from the main function, and then foo imports a bar package. And now bar references an interface that it's type hinting for, and that interface is declared in the foo package. So now that's importing foo again. Well, you can't do that in Go because this is called a package import cycle. And the solution to that will be to move the interface to the bar package or define another interface that the bar package uses itself. And remember that because our interfaces are implicitly satisfied, we don't need to have this import just to have interfaces satisfied by our types. Now, there may be other reasons for package import cycles, like certain variables, certain types you've declared. In my experience, you just need to start extracting those into other packages. Again, it just takes a bit of experience and a bit of going through that a few times to be able to avoid it. And the last thing I want to talk about was the fact that it doesn't have any generic support. So if you're coming from TypeScript and you use generic types quite a lot, you're probably going to miss them. Now, I've never, coming from a predominantly PHP background in recent years, I haven't really ever reached for generics to solve a problem. But if you want to implement like collections and things like that, you may have a bit of a difficult time. The good thing is that recently the proposal for generic type parameters has been accepted by the team. So they're now working on a solution based on that proposal. And we should expect to see that in Go 1.18. Now, Go does a feature release every 6 months. So probably February next year, in 12 months time, we should see generic types in the language. And this has been the number one requested feature for as long as I can remember now. So certainly for the last 3 years, and I think it's going to help push the language forward. So hopefully I've intrigued people to want to learn more about Go and also pick up the language and use it. So if that is the case, where do you go from here? Well, some of you may have seen the Go tour, and this is an obvious one, but is definitely the first place to begin. I haven't really gone through all of the type system, the functions, done deep dives into every feature that Go has, because it's very difficult to do that in a meaningful way in a 30-minute talk. But the Go tour is really good at getting that feel for the language. And I do think that if you've gone through the Go tour, which will take you probably 1 to 2 days at the very most, that you will be ready to start working on Go code. And then beyond that, I would go to the Go docs. Now, this isn't just a bunch of API docs like this function does this. It's got a lot of good guides in there for how to write Go code, how to work with modules, different concurrency patterns that you can implement to solve your problems. So this is a really, really useful resource. And then more recently, they've created this other website called Play with Go, and these are like more fun guides, a bit less serious, but they, there's probably only about 7 or 8 on there at the moment, but they may expand this a bit further. This is just something to be aware of. If you don't see something in the Go docs that you're looking for, that you could try this as well. Now, once you're working with Go, and this is the case for me, I've been working with Go for nearly 3 years now, or about 3 years, and I use this every day. So, Go by example, if you want to refer to, common patterns that the community's created on how to solve certain problems. In this particular case, common patterns for HTTP servers, taking you through the standard library and how you use the standard library to actually create and configure a HTTP server, all beautifully annotated as well. That really helps. So I think this is something that you could definitely bookmark and keep to hand. So I didn't do an introduction at the start. I like to do them at the end. I'm James. I work for Inviqa, and I've been programming professionally since I was about 20 years old. And then over the last few years, I've been working more with like distributed systems, microservices, things like that.